Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode problem of the day, and this is a very easy problem tagged by LeetCode. Although it is also easy, problem is binary gap. In this video I will give you the most optimal approach, and video process will be go this way. First I will explain the questions, then go through the approach, code explanations, and finally complexity analysis. Now come into the question part. Question is fairly simple. We have to find the maximum gap between two set bits in a given number n. Okay, so first of all you have to convert. Let's take an n equal to 22. Now if you convert this n to the binary representations, this will be the binary representations 1 0 1 1 0. And now you have to calculate that between two ones, any two ones, that those are consecutive distance between them. Let's say this one and this one. So what is the distance between them? It's 2. That means these positions you can consider 0 1 2 3 4. One position is at 2 and one also in the 4. So if you subtract these two things, it will give you 2, like gap between these two ones. And if you consider these two ones, this will give you the 1, because 2 minus 1, it will give you 1. So and if you have the only one, let's take an example of n equal to 8, it will give you the binary representations of 1 0 0 0, two consecutive ones gap. It will give you, now like there is only one, so you have to return just 0, just return it as 0 as question is given. Now come into the n equal to 5 part. It will give you the 1 0 1, and if you try to do the indexing 0 1 2, so it will give you the mod of 0 minus 2, it will give you gap is 2. This is the maximum gap. I think you got the questions correctly. And come into the approach part. But before going into the approach part, please like and subscribe the channel and comment that this is helpful. That will be great for me. Now come into the approach part. First of all, we have to iterate from the LSB, least significant bit, that is the rightmost bit. Let's take an example 1 0 1 0 0 1. So this is the least significant bit and this is the most significant bit. So we just try to go from right to left. We just iterate from right to left, and for each bit we just track a last set bit and the maximum gap. Last set bit means when we are in these positions, starting from these positions, so that's at that time last set bit you can consider is -1, like last set bit positions is -1. When you gone through this part, you just update our last set bit as 0, because you try to do this way, indexing 0 1 2 3 4 and 5. And when you are in that this part, you have the last bit positions is valid, then you can just subtract 3 minus last significant bit, that is 0, and take the mod. It will give you the gap between those two ones. So that is the simple idea. Now if the bit is set, as I already discussed, the last significant bit not equal to -1, that means last set bits is a valid bit. So we just update our maximum gap, and if it is not, that means we just update our bit positions as the last set bits, and at last we just return our answers. This is a very easy problem. Come into the coding part. First of all, we just initialize our maximum gap equal to 0 in case we did not found two ones, and bit positions also 0, and tracking the last set bit is -1, that means we have not seen any set bits. Now in bit positions we will iterate from 0 to 30 for the 32 bit representation. That means we just want to do this 31 shifts is possible. In first one we just n right shift bit positions ampersand with 1. If it is in that bit positions is set, that means it will give you the 1, and we just do our code accordingly. And if it is not set, that means we can skip that part, and bit positions plus plus. Now come into the, if it is set, that means in that the number n in that bit positions is set, that means we just update. If it is not last set bit not equal to -1, then we just update our answers, otherwise we set last set bit to bit positions. When we update our answers, we just subtract bit positions, like bit positions minus set bit. This will give us the gap between those two ones. And finally we just return our maximum gap and come into the complexity part. For time complexity, we just iterating 0 to 30, that means it will give you the big of 31. So you can consider big of 31 and you can consider big of 1 because it's a constant time complexity. And for space we are not using any extra space, so it will be big of 1 space complexity. So yeah, this is the optimal approach and the code. Thank you guys, thank you for watching, stay tuned for more videos.